So let's start with inserting a node at the end of the doubly linked list. So when we have to insert a node at the end of the doubly linked list, let's first see what are the operations we have to do, and then we will go on to write the complete code. So again, we have a node class here. We'll have data next prev, and we will create new nodes using this particular constructor. So there are various scenarios, right? So when you're writing the code, you have to keep on various scenarios. So one scenario is that my list is empty, and another scenario obviously is that list is not empty. So we will see what to do in both the cases. So first, let's say list is not empty. Let's say list is not empty. So let's say this is the list. I have to insert a node at the end. So what we will have to do? So currently the very first thing we have to do is we have to reach to this particular node which is at the end. So we know we have head, which is always pointing to the first element. So what we will do is we will make a new object of type node. Let's say we call it node temp, and we will try and make this temp point to the last element of this particular node. So how we will do that? So initially the temp will start pointing to the first element, and for that we need to do this node temp is equal to head. So whomsoever head is pointing, temp will start pointing to the same node. So initially both temp and head will be pointing to the first node. Now we will traverse through the doubly linked list to reach to the last element. And how are we going to traverse? Let's see. So we will run a loop while temp dot next not equal to null, temp is equal to temp dot next. So we will keep on updating my temp to point to the next element until we come to a place when the next of temp is null. If the next of temp is null, which means we are at the last node. So let's see how this happen. So initially temp is here. We check if temp next is null or not. So the next of this particular node is not null. So now temp will get updated and temp will start pointing to this particular node. We again check if the next of this is null, which is not the case. So again temp is updated to point to this node. We again check if temp next is not equal to null, which is not the case. Next of this particular node is not null. So we come here. So now my temp is here, and the next of temp is now null. So obviously the loop will be broken and we will come out of the loop. So now our first agenda was to reach at the end of the list, after which the insertion has to be done, and we have come here. Now what is the next thing? We have to create a new node. For inserting a new node at the end, we first have to create the new node. So let's say new node will have value as 8. So I create a new node, new node is equal to new node 8. So as soon as we do this constructor gets called. A new node is created somewhere in the memory. This is somewhere in the memory. It is not after this particular list, this particular node, or it is not at the end of the list. It's created somewhere in memory with next and prev both as null. It is somewhere in the memory. Now we have to bring this at the end of this list. How are we going to do it? So in order to do this, the next of this particular node should point to this newly created node. This we have already seen in linked list, singly linked list. But here we have to do one more operation. The prev of this new node should start pointing to this node. So the next of temp node will start pointing to new node, and the prev of new node will point to the temp node. So let's write it down. So temp dot next is equal to new node, and new node dot prev is equivalent to temp. So using this operation, our new node will be inserted at the end of the list. Now again, here we have considered that list is not empty. What if the list is empty? So even before doing these operations, these two operations, we first have to check that whether the list is empty or not. Then we should do this operation. So first we have to check for condition that whether the list is empty or not and take care of that condition, and then we should do it for list is not empty. So how do we know that list is empty? So if head is equivalent to null, which means that the list is empty. So in this case, what we will do is we will simply update our head to point to the new node. So again, let's say this new node is created in the memory, the list is empty. So if the head is null, list is empty, which means that this is going to be the first element of that doubly linked list. So in that case, we will do nothing but just we will make head to start pointing to this particular. So we have seen that we got a list like this till now, 5, 4. So we got a list like this till now using insert at beginning. Now let's say I want to insert an element at the end after 4. So let's say I want to insert 8 here. Now how do I do this? So we will see using insert end that how can we insert an element at the end of the list. So for this, let's call dll.insertEnd from here 8. So obviously we are not having the method insertEnd, so this is going to give me an error. Let's define the method insertEnd. So when we are doing the insertion at the end, again the first thing that we will do is we will create a new node. So this gives me a new node with data as 8. So whether you are doing the insertion at the beginning or at the end, or generally what we do is we write one method for insert and then we handle both end and beginning at in between the nodes in the same method. But since here we are writing the different methods, so every time we are trying to insert, we have to check that if here we know that head is not null, we have done the insertions, but we have to check that whether head is equivalent to null or not. So we do the check that if head is equivalent to null, we simply update our head is equal to new node. But here in this case, we know that head is not null. So what we have to do is we have to insert the element at the end. So let's see the operations that we are going to do. So for inserting an element at the end, we first have to reach to this particular place. So how can I reach there? We can reach there using the while loop, as we have seen that while discussing. So we create a new node, temp node, which initially points to head. So we cannot use the head to traverse through the list, because in that case we will lose reference to the first node, which we don't want. So we take a new temp node which will be pointing to initially the first node of the list, and this temp node will eventually go on to point to this particular node. So we will traverse this complete list to come to this particular place. So we do while temp node dot next not equal to null, temp node equal to temp node dot next. So how do we know that we have reached to the end of the list? So in case of doubly linked list or singly linked list, we know that we have come to the end when the next of a particular node is null. So here we are doing the same thing. We are checking if the next of this is, so let's say initially temp node is this. We check that if the next of this is null, which is not the case. So we update our temp to point to the next node, which is this node. We again check if the next of this is null, again not the case. So we update the temp node to point to this node. So here what will happen? The next is null, this particular loop gets broken, and we get our temp node to point to this particular node. Okay, now let's see that once we have temp node with us, so the next of temp node starts pointing to the new node, and the prev of new node starts pointing to the temp node. So now let's see whether this is working fine or not. So what we are doing is, our temp node is here. We created a new node. Okay, sorry. So we did a mistake here. We had to insert an element after 4. So initially our list was like this, 5 and 4. And we had to insert 8 after this particular node. So what we do is, we reach till 4. Our temp node is at 4. Our new node 8 is created somewhere in the memory. So in order for this to come after 4, the next of 4 should start pointing to 8. And we also have a prev here. So the prev of new node should start pointing to 4. So this is what we have done here. So now our list is like this, 5, 4, 8, and the next is null. Now let's say I want to print this list through running this code. Before that, here again we have to add the return statement, which we missed, so that the method returns from here if head is equivalent to null. Now let's see that how do we print a list. So we will write the method for printing the list, and we will print this particular doubly linked list that we have formed. So let's write down the method for printing the list. So let's say I called print list. So we will use temp node to traverse through the list and print the values. So we keep on traversing through the list unless temp node becomes null. And while we are traversing through the list, we will keep on printing the values. Temp node dot data. And after we have printed the list, let's say I print list is printed. Let's call this particular print list method from DLL main. So let's call it before insert end and after insert end. So I call DLL.print list 2 times. Now let's run this particular code to see that what is the output that we are getting. Okay, so what happened before? This is the first print list. So we had inserted 5. So we had inserted 4 and then 5 at the beginning. So initially we had this particular list 5 and 4, and you can see in the output we have 5 and 4, and then we inserted 8 at the end and we had this list 5, 4 and 8, and you can see that 5, 4 and 8 is printed. So we have seen inserting at the end and inserting at the beginning. Now talking about the time complexity of inserting at the end. So the time complexity for reaching to the end will be O of n, because we are traversing the list to reach to the end, and the time complexity for inserting at the end is going to be O of 1.